Further transcendental functions. So we already wrote memorization cards for these, so I'll just kind of do a couple examples to make sure you got it. Okay. So let's evaluate. Remember, it can be written as that. Right? You okay with that?
How did you have it before?
I would put a 1 here and a dx out here.
Oh.
That's how I usually do it. It's the same thing. So which inverse trig function is that? Yep, tan inverse. Don't get confused, that's an x squared, right? But that's a part of the formula. It ends up as an x here. Don't put x squared there. Okay. A part of the formula. Yes, I know it's weird and it's funky, but what's the tan inverse of 1 minus the tan inverse of 0?
Why is it an inverse? Just because that's how we decided it? Or
It has to do with the Taylor series expansions of these functions.
I don't know. Never mind. Okay.
So this is BC calculus.
Yeah.
You just need to remember it. It's my advice. So anybody, how do I think about this? Okay, this is how I think about it. This is when tangent x equals 1. Where is that? On the English circle. Pile 4. This is pile 4. And where is tan x 0? That's where cosine is 0. Or sorry, sine is 0. So that's right at 0, correct? Okay. You need to be lickety split on these trig functions.
Wait, what do we do?
So that's it. That's the answer. The inverse, this is the same thing as saying tan inverse of 1.
Really?
Yes. That means that tangent equals 1. What? No, it's, okay, remember, if I have that right triangle, I would pick tangent because it's opposite over adjacent, right? I'm trying to give you a little background here. So tan theta is 2 over 2. How would I solve for theta? Yeah, it's the tan inverse, right? That's what that is. You're trying to find the angle measure for this angle. That's why the tan inverse exists. Instead of like with tan, if we have the angle measure, we would try to find the side. Like, okay, so back and forth there.
And we have to read that stuff times that?
Oh, this? No. Totally trigonometry. You'll have to maybe do a related rates problem with it.
Well, we can go back.
Wait, so you're saying that's too easy?
No, this might be on the test as a related rates problem or something. So you might have to use it. Yeah. So. Let's.
35-year-old uncles taking these classes. Like we were talking about it the other day when you came over. Because I'm like, God, you guys have that weird one. Yeah. It was so weird.
Funny thing is, they do this whole class in a semester.
Yeah, he's in his first semester.
Calc 1.
Yeah.
Who's his teacher?
I didn't.
You should ask. I probably know
Okay.
who it is.
Well,
I like the math professor there.
in general,
That's where I went to school.
Oh, I thought we went.
No, I grew up in Alaska.
Came here as a
No, I didn't grow up in Alaska as a child.
Oh, you don't get
I
them.
moved there as an adult.
Yeah, I
Aren't there stories having?
No, it's not story time. It's time to move on. No. Does that match any of the inverse trig functions that we have on our list? No, it doesn't. Right? And there's the next element. But it's very similar, right? 1 over the square root of something. Is there a way we can make it one of those?
Sure.
Is there a square root of or x squared minus 1 by chance?
Wait, what is that?
There is. Good. So that's probably where we're gonna head, right? Sure. You can rewrite this. If you want it, you need to use some. Oh, 1 divided by root 2. That could change things a little bit.
Very good.
We can rewrite it as such, yes. 4 is 2 squared. So it's 2x, all the whole thing squared. If I substitute u in for that value, u is 2x. And what's du? Is there a 2 in here? Here. Okay. So we have to divide it over, right? Have we taken care of that x yet? Where? Is there an x over here? There's not. We have not replaced it yet. But it's right here, correct? So, but I just need x, I don't need 2x. So I can substitute that in here as well. And once it's divided by 1/2 means you multiply by.
What?
Oh, sorry.
Okay.
Thank you. So use substitution, that's just a little manipulation on it. You might have to use this twice. Now I'm going to take this out here. It's the same thing as multiplying by 2. So these actually disappear. What are my new limits though? 2 over root 2? And 2. What's the integral of that? Unfortunately, this is an x value. Plug it in for x.
Okay.
And it gives you the u value. So now we don't have to worry about putting x's back in here. We're all in use. This is secant, right? Secant inverse? Yes. So 2 minus 1. Thank you for asking. Do they tell us why we don't have to worry about that?
Where
Why do we not have to worry about this being absolute value, which is the formula?
Between two and two and one.
Positive. Right? It's all in the positive land, so we don't have to worry about this being. Okay, thank you. Now evaluate.
You could put that in your calculator.
It's calculator friendly section of the exam. Is root two, is 2 over root 2? No! Is 2 over root 2 a unit circle friendly?
No.
No, it's not. Wait for it. The unit circle, remember, doesn't have any roots in the denominator. So we can manipulate it. 2 root 2 over 2, which is square root of 2, right? So to make a unit circle friendly. Or I took that.
Yeah, what is that? Is that theta?
It's a 2. It's supposed to be a 2.
Oh, you just brought the denominator out?
Yeah, I just made it a denominator.
Oh,
So the other way to think about this is to leave it 2 over root 2. Secant is the inverse of cosine, right? The reciprocal of cosine. Cosine can be root 2 over 2, correct? Where does that occur? Where's cosine? Everything's root 2 over 2 at pi over 4. Okay. Good check. Yes. And this is at pi over 3. Because cosine is 1/2. Right, at pi over 3? See how we're thinking in terms of cosine here? We go rage like it did when the electricity went out earlier. Yes, ma'am. No, he's not here to install it. He's here to trade it out. I gave Tracy the old one. It should be up there. And then he's supposed to give you a new one. He's from Lowe's. No, I don't. Okay. Well, thank you. Bye. That was very urgent. Oh. The old one's up front.
I grabbed that one for all. Is that all?
That was it. Okay. Good. Merry Christmas. This is power 12. Thank you. Okay, let's do one more and we'll be done. Just one. This is just something you have to memorize. It's that formula that we put on the card earlier. So what's the integral of 7 to the x? It's oh, and 7. Yep. And then evaluate it from 5 to 3. Pretty good. All right. So you'll be using some more U substitution and get some practice there. This is due Tuesday. Hey, Kaylee.
Not one for like 50. Okay, I think it's, I wrote it down as 1 to 11, but I wrote my O too close to my 1 for just kind of connected. So I thought that was 1 to 16. Yeah, that's why I was so confused. I was like, why didn't you want to do this on homework?
I didn't.
I gave it to
That
myself.
free response is an ellipse. Last year, conic sections.
Oh, try to block
So
that out.
this is gonna be content, since there's no.
We have
This has to be.
Tuesday 5.8. Or Tuesday we can do the velocity acceleration thing. That's fine. Wednesday 5.8. Thursday's review, Friday test. Okay. So start looking through those cards this week and memorizing stuff. It's about half integrals, half everything else. Okay, one morning.
Want your cool little thing?
Yes, it's called a breaker.
It breaks.